IBM Demos lets you experience Red Hat OpenShift on IBM Cloud, Cloud Packs, and other IBM products by providing hands-on lab environments. Let me introduce the Red Hat OpenShift on IBM Cloud Lab. Here, you're able to get an introduction to Red Hat OpenShift and provision applications, work with the operator framework and integrate with CloudHand, as well as perform log analysis with LogDNA. After clicking on Launch Lab, you will be immediately taken to your lab. On the left-hand side, you'll be given instructions, and on the right-hand side, you'll find a terminal where you can type those instructions. As you can see, this is a Linux environment. On the top, you'll be able to find the necessary access information for all the relevant consoles. For example, the dashboard URL and the overview URL. The dashboard URL takes you to the OpenShift console. Let's test this out. Cool. Let's go back and let's test the overview. The overview takes you to your IBM Cloud virtual account, where you can see the cluster that you have provisioned. Note that this is a demo environment, and you will not be able to extend your cluster by adding additional worker nodes or working with worker pools. Notice that you have 2 worker nodes and they're in the state of normal. I can confirm this by clicking on the Worker Nodes tab. Note that the version is 4.3.23. If I hover over the actions, I'm able to select Update Version, Delete Cluster, Connect via CLI, Web Terminal, or if I hover over the OpenShift Web Console, I'm also redirected to the OpenShift console. So let's go back to the OpenShift console and let's see if the worker nodes that were being shown in the IBM Cloud portal can be found here as well. If I look at my dashboard within the administrator view, you'll see under cluster inventory that I have 2 nodes, 77 pods, 20 storage classes, and 1 PVC. So let's take a look at the nodes. You will notice that the IP information matches the information that you had from the IBM Cloud dashboard. In the next steps, we're going to explore the OpenShift console. So let's take a look at exercise 1. We've already seen how you can access the OpenShift dashboard, the IBM Cloud dashboard, and within the OpenShift web console, we're going to take a look at a couple of things. The different perspectives available, administrator and developer, the capabilities available in each perspective, and also take a look at some items such as the number of nodes, the standard services deployed in a default project, and the operators that are installed on our OpenShift cluster. In the OpenShift console, first I'm going to focus on the administrator view. Notice that as an administrator, I can work with operators, workloads, networking, storage, builds, monitoring, compute, user management, and overall cluster administration. I'm going to now switch to the developer view, and as you can see, the focus is on creating applications, building applications, and monitoring applications. When you look at the topology view, you'll see that you can create a new application, starting from Git, a container image, a Docker file, YAML, a database, and more. You'll also notice that we have a default project. This is the equivalent to a Kubernetes namespace. Within our project, You can create applications. Let's say you're going to name your project development, or you're going to name your project my application. And these are isolated when it comes to resources from other projects. So you have separate visibility, you have separate role-based access control. So I'm going to just create a new project, and I'm going to call it my project. I'm going to give it a fancy display name and a description. As you can see, project auto-provisioning is enabled in this cluster. Let's finish exercise 1 by looking at the operator framework. Within the operator framework, you'll see both installed operators. So here, within all projects that have just one operator installed, but also the operator hub. And this lets us install community and Red Hat operators. So you can see here in terms of capability level, you can have extreme automation. So Autopilot, for example, and Deep Insights provide very high level of automation, and they typically do all the things that are included in basic install, upgrade, full life cycle, like high availability, disaster recovery, backup, logging, monitoring, analytics, and some extra things on top. So if you want to deploy, for example, MongoDB, you can click install and the operator will be deployed onto your cluster. You can also choose how this will be installed, right? A specific namespace. So let's say I just want to install this within my project, or if you want to install it on all namespaces. Now that we have our operator installed, well, almost there, we'll be able to take a look at the deployment, user, and ops manager APIs that this operator provides. It's up and running. It's successfully deployed. So let's take a look at the deployment API. As you can see, creating a database with MongoDB using an operator is a lot easier than going through this process by yourself. Looking back at the administrator view, you can also see some of the cluster settings here. For example, you'll see that we're running version 4.3.19. You can take a look at the namespaces, resource quotas, limit ranges, and custom resource definitions. Under compute, you'll also be able to find the nodes. We're going to move on and take a look at some of the application deployment in our next section. In exercise 2, we're going to use source to image to deploy a simple Node.js application. Within the developer perspective, we're going to first create a new project. We're going to call our project example health. We're going to optionally provide a display name and a description, and we're going to select from Git. This will allow us to use source to image to deploy our application. We're going to provide the repo URL, and we're going to use the URL here. And we're going to make sure that as a builder image, Node.js is selected. As you can see, we're also going to name the application. So just to give it a meaningful name, we're going to use a deployment, and we're going to create a route so the application can be accessible externally. Within a couple of minutes, the application should be deployed, and you should be able to access the application within this topology view by clicking on this anchor. Once the application is deployed, you can sign in using test. Obviously, if this was a production application, you would store this in a secret. And if you're able to log in, the application has been successfully deployed. Let's do this now. To deploy our application, we're first going to create a new project. Within the developer view, click under Projects, Create Project, and let's call it Example Health. Now that our project is created, we're going to use Source to Image to deploy the application. Select from Git and provide a URL to the Git repository you want to deploy. Make sure Node.js is selected as your builder image. We're deploying a Node application, we want to make sure that this matches. Select the right version. Here we're going with version 10. Give your application a meaningful name. Select the type of resources to generate. You can either generate a deployment or a deployment config. Here I'm going to use deployment config and create a route to the application. Once this is in place, click Create. Your application is now being deployed. Within the topology view, you can see the builds, you can see the source code, and you can see the URL to your application. Let's take a look. The build is currently running. You can view the log files, or you can look at the services, routes, as are also available through the topology view. So let's take a look at the log files from our build. We're cloning the repository. We're creating a container image. We're writing the image. We're pushing it to the integrated container registry. And the push is successful. Our build is complete. Going back to the topology view, let's take a look at where the application is. Build complete, container creating. So let's take a look at this. The application is started and is actually running on port 8080. Taking a look at the overview. We should now be ready to explore our application. Going back to the topology view, I'm going to click on Open URL to take a look at our running application. Log in with test. Obviously, you would change this to use secrets in production. This concludes our application deployment. In exercise 3, we're going to explore the console. Within the web interface, go to your username and click Copy Login command. This will give you the OpenShift OC login command and the token. You will paste this into your terminal and you'll be able to access OpenShift using the command line. A bit like this. One of the first things I like to do when working with Kubernetes or with OpenShift is to set up tab completion. You can do so using the OC completion, and then you're going to either say bash or you're going to say Z shell or whatever shell you're running, and you can either output this to a file like Z shell completion, and then you can source this file, and you can do so as part of your profile, or you can copy it to etc, or in one step you can do it like this as well. And now we have tab completion set up for OpenShift. With this in mind, let's take a look at a few useful commands. So OC who am I gives us our identity, And you can also use things like show console. So you can get the console URL. You can use show server to get the API URL. This is the same URL that you've logged in using the console. Or you can get things like the token. You can also get information about nodes and pods and a lot of things with the get command. So let's take a look, for example, at the OC-get nodes command. So OC-get nodes, and we should see the two nodes we've seen through the web interface. If you want to get more information, we can add -o wide. And if we really want to get a lot of information, we can use the YAML output mode, and this will give us quite a lot of information. So going back to the wide mode, I'm just going to take the name, which is actually the IP as well, of one of these nodes, and see if I can get some details. And I'm going to use the describe command. And I'm describing a node. And I'm going to get information like the request, CPU, memory, storage. So let's scroll back up here to see some of the information that we're getting from this OC describe command. It doesn't look like we have any issues with this node. So let's explore a few other get commands here. So you can obviously use something like OC-get-all. And if you want a lot of information, you'll say OC-get-all -all namespaces, for example, to get everything, all of the resources across this, all of the namespaces. Or if you want to be more specific, you can say which object you want to get. So let's say you want to get, for example, SVC, deployment, PO, and you can specify which namespace. For example, if you just want default, you say -n default. Let's explore the projects as well. So I'm just going to type OC projects, and since we're actually a cluster admin, we see a lot of projects, and let's see if we can find our health project. And we're going to switch to this one. And now that we're typing the OC-get-all command, we're now actually within the namespace of our health application, and you can see some of the pods that are running and complete it and get additional information. In exercise 4, we quickly explore logs and events. Within the topology view, click on your pod, and you'll be able to either view the logs directly or explore the pod information, environment, and logs. Within the developer section, you can also see the events tab. If you click it, you'll be able to see, let's say, a timeline of the events. In exercise 5, we're going to take a look at monitoring. So from the monitoring tab, select the dashboards, log in with OpenShift, and this will take you to the Grafana dashboard. Allow selected permissions so Grafana can actually access OpenShift monitoring. And here, within the Grafana view, you'll be able to access your applications. So let's take a look. If you click on Home, let's select the information about pods. Let's select a namespace. Here, we're going to select our example health. I've selected the running pod, and I'm getting information on CPU usage, as well as memory usage for our application. You can get additional information here. Cluster information, for example, can be found within the cluster section. In exercise 6, we're going to work with DeploymentConfigs. Under DeploymentConfigs, we're going to change the spec. So we can define how many resources our pod requests and what the limit of those resources looks like. And then we're going to look at some auto-scaling. If you look at the spec, you'll see we haven't defined any resources. So we're going to define here limits, and let's say CPU, define a very small CPU limit, and memory 100 MI. If your CPU is going to be too low, your application will slow down. If your memory is going to be too low and your application consumes more memory, your pod will be destroyed, and based on the restart strategy, it may be restarted. Requests, this is how much is going to start with. Requesting 330 M, memory, let's go with the same values here. This value basically means, so 1000 is 1 vCPU. So 30 is going to be very, very low. We're going to save. And going to the overview tab, you see now we have a new deployment configuration. The latest version has changed. The resources that we've set are here. And now we're able to scale our application. So let's scale it to down to 0 first. As you can see, the pod has been destroyed, or up to 2. One pod, and we have a second pod that is now being created. Now we have 2 pods running. Let's take a look at the Horizontal Pod Autoscaler. I'm generating some load on my application. And if you can take a look at the deployment config, you will see that I have 1 pod. By creating a Horizontal Pod Autoscaler, I'm able to scale this out. Here, I'm using a deployment config. I'm scaling to a maximum of 10 replicas. And I'm scaling based on CPU utilization. I'm using very low values to ensure that I'm able to see this in real time. I've created my Horizontal Pod Autoscaler. Remember, there is 1 pod running right now, but the Horizontal Pod Autoscaler has already changed its target to 4. Now I have 4 pods running. Five, 8. Once we can see that this works, we can edit the configuration and change the average value so it scales to something a bit more reasonable. So let's say this was 100. This has been already modified. Let me edit this again. So let's say this was 100. a bit tricky as this keeps changing quite fast. So I've updated this to 100. So now we have 10 pods, but the number should now go down as the workload is actually decreasing.